Evaluation of real definite integrals. Residue theorem helps us to find a simple method to evaluate many important definite integrals of real variables. Integrals of the type integral 0 to 2 pi f of cos theta sin theta d theta, where theta varies from 0 to 2 pi, actually indicates integration around unit circle modulus of z equals 1. In such questions, when you substitute z equals e raised to I theta, you have taking derivative on both sides of this equation. Dz equals I times e raised to I theta d theta. Also, 1 by z from this expression is obtained as e raised to negative I theta. When you evaluate z plus 1 by z, you have e raised to I theta plus e raised to negative I theta. By Euler's identity, we have e raised to I theta equals cos theta plus I sin theta, and e raised to negative I theta equals cos theta minus I sin theta. Hence, z plus 1 by z is evaluated as 2 times cos theta, from where we have the relation cos theta equals 1 by 2 times z plus 1 by z. Similarly, we have z minus 1 by z equals e raised to I theta minus e raised to negative I theta. Using Euler's identity, we have z minus I theta equals 2I sin theta, from where we have the relation sin theta equals 1 by 2I times z minus 1 by z. Hence, any integral of the type integral 0 to 2 pi f of cos theta sin theta d theta can now be replaced by closed integral over C f of z plus z inverse upon 2, comma z minus z inverse upon 2I. We have just substituted cos theta equals z plus z inverse upon 2 and sin theta equals z minus z inverse upon 2I. And we have d theta equals dz by iz when we depended on the equation z equals e raised to I theta. We have this integral of the form integral over C f of z dz, which is line integral over a closed curve, and we have by residue theorem integral over C f of z dz equals 2 pi I times sum of residues of poles lying inside C. We have reduced integrals of this type to complex line integrals using the substitution z equals e raised to I theta, and we have used residue theorem to find the value of integrals of this type, where f cos theta, sin theta is a rational function of cos theta and sin theta.